Good day, class. We're back and we're now on the fourth quarter, and we'll continue our lessons in statistics and probability. And for this week, we are focusing on the hypothesis testing. And if you would recall, previously we talked about a lot of things, no? Illustrating the student's t distribution, identifying the percentiles using the student's t table, identifying the length of a confidence interval using both the normal and the student's t, computing for the length of the confidence interval, and computing for an appropriate sample size, okay, using the length of the interval, and solving plenty of problems involving sample size determination. Now, for this week, we're going to learn about null hypothesis, alternative hypothesis, levels of significance, rejection region, and types of errors in hypothesis testing. Must be exciting, okay? Identifying the parameters to be tested given a real-life problem. You see, class, we are now focusing and going towards the application of what we've been learning in the past weeks, okay? So if you're ready now, let's get it on.
Welcome everyone to my channel. My name is Mon. Sir Mon.
Now, we always use and go back to this conversion formula, calculated z or t, depends on the given. So we have x bar minus mu over sigma over square root of n, or x bar minus mu over s over square root of n if you're going to use t, and you know when to use t. And there is this for proportion, okay, p hat minus the population p, which is the proportion, over square root of pq over n. And if you notice, there is no t-test for proportion. Okay, take note of that. So you only have these three very similar and very easy to remember formulas. Okay, now I'll give you more example on that later, but for now, I want you to take a look at the rejection region when there is a two-tail. Okay, we're not talking of rejection. When do you reject? Okay, of course, we have to graph first the rejection region. If the calculated statistic is less than negative z, okay, if your calculation, the one that, this is your calculated statistic, the z, t, or z, okay, if your calculated z, t, or z again for proportion, is less than negative z here, okay, then you will have that area as a rejection region. Or if your calculated z is greater than the z here, okay, the value here, then that belongs here in this red area on the right. Okay, now the probability of committing type 1 error, remember, is less than the significance level of alpha. Okay, or in this case, less than alpha over 2 if you have a two-tailed. Okay, take note of that. If you have questions, we'll discuss that in class. So therefore, if your probability of committing type 1 error, which is your basically what? The calculated z less than or equal to the value that your, the probability that your z is less than or equal to calculated z. Okay? And I will explain that further in more concrete example, okay? So, if the probability of committing type 1 error is less than the significance level, alpha, then that belongs to the rejection region. Now, if there is a one-tail, okay, we are talking only of the negative z here, and if your calculated statistic is less than this value, then therefore it is within this area, and therefore you reject it because that is your rejection area. What it means is that the probability of committing a type 1 error is less than the significance level given. Okay? And then also if it's on the right side, if it's greater than the calculated statistic is greater than the z, okay, it falls somewhere here on the red area, or the probability of committing a type 1 error, again, is less than the significance level, then it falls within this area, and therefore you will reject. So you now have different rejection regions depending on whether it's two-tailed or one-tailed. Now, let me give you exact or more concrete examples, okay? But for now, I want you to, again, answer the Mentimeter so that I would know, so far, how did you understand the concluded sessions. Let's now go to the application. Fail to reject is my first example. Suppose it is known that the population has a mean of at most 15, at most, and a standard deviation of 8, and a sample size of 36 was randomly selected. If you decide to reject the null hypothesis, when the sample mean is 17 or greater, calculate the probability of committing a type 1 error. So I want to know my probability of committing a type 1 error. Okay, now let's take a look at this. The null hypothesis would say that the mu, or the average, is less than or equal to 15. Why? Because it is at most, right? So that's the maximum value, so all the other values could be less than. Now, because of that, the opposite is that the alternative would be mu is greater than 15. And using this conversion, my z value would be x bar minus mu over sigma over square root of n will give me 17. Okay, that is my assumed x bar now from the sample. And the population mean is 15. Okay, divided by sigma over square root of 36, which is your n. So your sigma is 8. And therefore I get 1.5. Now, I want to go to the probability that x bar is greater than 17, which is equal to the probability that z is greater than 1.5. Okay, and because it's greater than 1.5, positive, it's also the same as less than negative 1.5. Okay, as you have learned in my previous lessons, because of the mirror image. And therefore, looking at your standard normal table at z less than negative 1.5, I'll get 0.0668. And that is the probability of committing a type 1 error. Okay? That is my probability, committing a type 1 error. Rejecting. If I reject it, I have a 6.68% chance of error. Now, the next question is, do you reject HO? The answer is, it depends on your level of significance. If your alpha is set at 0.05, then you do not reject the null hypothesis. Why? Because you're saying that you're allowing yourself a 5% error, maximum of 5% error only. But in your calculation, you're getting a 6.68%, which is higher than the 5% that you're setting. And therefore, I do not want to take a risk more than my preferred risk of 5%. You get the point? So, when your actual probability of type 1 error exceeds, okay, the one that you are tolerating, which is 5% in this case, your alpha, okay, then you will not reject the null hypothesis and probably just stick to it for the meantime until further data will come in and therefore come out with something that would really reject and show that it has changed already. But if there is no data yet to support you, they might as well maintain the null hypothesis and do not reject it. Okay? So here is another example. If you look at the values, at 5% on the right, you will have a 1.645 as your tabular, okay, based on the table. That's why I call it tabular value of 1.645. But the one that you calculated is only 1.5. So your 1.5 is left of 1.645. Okay? That is the other way of checking whether you are going to reject or not. Okay? Compare the calculated. Your calculated is 1.5. Right? We calculated it. But the tabular value is 1.645 for a 0.05 alpha. Okay? If the 1.5 is on the left side of 1.645, therefore it's on the white area. And therefore, because this red area is your rejection region, it does not fall within the rejection region, and therefore you don't reject. At 0.05, okay? At 0.05, I'm talking about alpha equals to 0.05. Let's have another example here, wherein we will reject. Suppose it is known that the population, again, has a mean of at most 15, okay? And a standard deviation of 8, the same given. And this time around, the sample size is 50. Again, you decide to reject the null hypothesis when the sample mean is 17, or greater. Calculate the probability of committing a type 1 error. Now, this time around, I have a 50 as my n, so I end up having 1.77 as my calculated value. And therefore, the value of the probability that z is greater than 1.77, which is the same as the z is less than negative 1.77, will give me only 3.84%. Okay? Since 3.84% is much less than 5%, which is my maximum allowable error, my alpha, okay, then I will now have a confidence to reject the null hypothesis. And therefore, I will now reject that it is the null hypothesis that it's which is 15, okay, the average of 15, and therefore I will now change the new standard of the average. Okay, now if you look at it, the probability of unfortunately the 1.645 is here, and okay, so this is your area of rejection region, okay, the 0.05, but I'm having a 0.0384. If you look at the values, okay, I ended up with 1.77 as my calculated z, okay, 1.77, and now remember that the point on the x-axis that refers to the 0.05 alpha is 1.645, and therefore your 1.77 is greater than 1.645, and therefore it will fall within the red region. Now, because it falls within the red region, I can now reject the null hypothesis. It lands on the red area or the rejection region. Got the idea? Okay. Now, let's take a look at this summary. When to reject the null hypothesis? The first rule is that when the calculated probability of error is less than the level of significance. Okay? In this case, 0.0384 is less than 0.05. I can now reject. The probability of committing a type 1 error is less than the probability that I set as my level of significance. Okay? The next way of knowing when to reject is when the calculated z value lies inside the rejection region. In this case, the 1.77, okay, this is the one starting from the black. The 1.645 is the start of the red area here. If you look at it, this is where your 1.645 here is located. But your 1.77 obviously is on the right side of 1.645, and therefore will fall inside the region, the red region or the rejection region. And that is when the calculated z value or t value, depending on your statistic, right? If it falls within that region, then you reject the null hypothesis. Okay? Quite easy, right? So again, this time around for activity 2, I want you to show your solutions. I have here the question. Suppose it is known that the population has a mean of 15, looks very similar, and a standard deviation of 8, and a sample with size 50 was randomly selected. If you decide to reject the null hypothesis when the sample mean is 17, calculate the probability of committing a type 1 error. And the next question is, are you going to reject the null hypothesis at 0.05 alpha? Remember, the given is that it is known that the population has a mean of exactly equal to 15 and a standard deviation of 8. Think before you click. Again, when you're done, put your answers on the chat box. And your 10 minutes start now. Let's compare our answers, okay? Suppose it is known that the population has a mean of 15. Exactly 15 does not say greater than or equal. It doesn't say at least. It doesn't say at most. So I will now have a null hypothesis of mu equals to 15. And therefore, this is two-tailed. And I will divide my alpha by 2 because my alpha will now be separated into two sides because I now have a two-tailed test. So I will now have 0.025 on each side. Okay? So our null hypothesis of mu equals 15 will have an alternative of mu not equal to 15. And using the conversion, again, I will end up with 1.77. Okay? And if you look at it, the probability that z is greater than 1.77 is equal to the probability that z is less than negative 1.77. And again, I'll get a 0.0384 or 3.84%. Now, I'm comparing it to 0.025. And since 0.0384 is greater than 0.025, we cannot reject the null hypothesis. Okay? Why did I compare it to 0.025? Because I'm dividing, okay, the alpha, the total of 0.05 into 2. So I have 0.025 on the left and 0.025 on the right. Now, the 0.025 on the right, if you look at your table, is from 1.96 going up. So it's the same as the probability that z is less than negative 1.96 if you look at your table. So 1.96 is the crucial or a critical point, okay? And that gives you the area above 1.96 will give you 0.025. Now, the calculated z, okay, the 1.96 is the tabulated z. The 1.77 is your calculated z value, which is, if you look at it, way outside of the red zone or the red rejection area. So 1.77 is before 1.96. If it happened to be 1.97, 1.98 or 2 or greater than 1.96, therefore it will fall within the rejection region. We can reject. But this time, my calculated z value is 1.77 only. Okay, if you look at it, it's outside of the rejection region. And therefore, I cannot reject the null hypothesis. You got the idea? First, the probability is greater than your alpha over 2. You do not reject. And the next one is that the calculated z value is outside, okay, the rejection region. And therefore, you cannot reject. Well, there you go. Our activities are done. And I hope you check your LAS or any online activity for this topic. And if you have questions, you let me know. And thank you again for attending our session. Okay, I want you all to submit your the activities that we have done into our Google Classroom. Okay, and keep safe, everyone. Bye for now.